Hello and welcome to the video on subnetting a network. So we're going to look at how we can take a single network address and break it up into multiple network addresses. So keep in mind that every network that exists is a subnet of other networks. Your ISP has a network, they subnet you a section of that network. There's also network address translation and other things going on. But for the purposes of this, we're just looking specifically at how we can mathematically subnet a network. So we're going to do a lot of examples in this video. We're going to start with the IP address 209.192.64.0. So this is a /24 network. So I'm starting off with something you're very familiar, a class C network, so /24, and we're going to break it into two networks. Okay, so if we look at this network address space, the network address is 209.192.64.0 if we write that in binary. So we have 209.192.64.0 written out in base 2, so binary. That's our network address. We know it's a /24 network, so if we count the first 24 bits, those are our network bits. So we have 8 bits, 16 bits, 24 bits. So the separation between our network and our host bits occurs right here. So if we're looking at the network address is the address where all of the host bits are 0. So it's the one we're seeing. The broadcast address is the exact same address, but where all the host bits are 1. So everything before the network break stays exactly the same. This is the network portion of the address. And everything after, so the host bits, all become 1s. So we know that our network address space is starting at 209.192.64.0 and going to, so that's our network address, and going to a broadcast address of 209.192.64.255. That's our broadcast. And a broadcast address is always the address where all the host bits are 1, and the network address is always all the host bits are 0. Okay, we're going to be using this information throughout these conversions, so it's good to have a familiarity with our address space. So we know that because this network goes from 209.192.64.0 to 209.192.64.255, we can be pretty I forgot a 5 there. We can be pretty sure that we're not going to have any addresses that are smaller than this and not going to have any addresses that are bigger than 209.192.64.255. So we're going to look at breaking it into 2. So in order to break this network address up into 2 different addresses, we're going to need to borrow some binary bits. And in order to get 2 different states, we're going to need exactly 1 bit. So we can have 0 or 1. Those are 2 possible states for this binary address. So what we're going to do is we're going to write our network address in binary. So we had 1101.0001.1100. This is 192.64.0. And actually, I'm going to go ahead and I'm going to write the host bits in a different color. So I'm going to say, okay, host bits are white. And if we're looking at this network, we know that it was previously broken up right about here. But we need to borrow 1 more bit. So we're going to borrow this bit. And we're going to we're going to turn it into a network bit, essentially. So everything up to the dotted line stays the same, so I'm not necessarily going to write it in. So we're going to end up with all the host bits are 0, the same network address. So this becomes essentially a temporary network, or for the subnet, this becomes a network bit. So, but our host bits are all going to be, so that's our network address, and our broadcast address, all the host bits are going to be 1. So notice this host bit, the first host bit here, is now a network bit. Okay, so that's our first subnet. Our first subnet, all the host bits are 0, all the host bits are 1 for the broadcast. If we do the next address, so this is the state of 1, we're going to have a network and a broadcast. And for the network, all the host bits are going to be 0. And for the broadcast, all the host bits are going to be 1. So for all of these addresses, the 209.192.64 portion of the address is still there. I just took it a little bit easier and didn't write out that portion because we didn't need it. But I'll fill it in now to clarify. When you first start doing this, I strongly recommend you do fill in all of the binary values. Once you get a little bit more familiar, you cannot include the octets you know aren't going to be affected by this particular address. So in this case, the first 3 octets aren't going to be affected, so you wouldn't need to include them. So if we're looking at this, subnet A is going to be these 2 addresses. And the first address is our network. So the network is going to be the same 209.192.64 and we're going to look right here at these bits and we'll see that it's still .0. The broadcast, I'm just going to leave that in view. The broadcast address is going to be 209.192.64. And this time we're looking at this address where all the host bits are 1. So in this case, we're looking at 1, 2, 3, 4, 5, 6, 7 ones, which is going to give us a broadcast address of 127. Okay, so that's our subnet A. Subnet B starts at the network. So the network address for subnet B is going to be 209.192.64.128. We're getting that from these 2 addresses. So this is our network address, and then our broadcast address is going to be 209.192.64.255. Now what you'll notice about the first network address and the last broadcast address is that they match the network and broadcast addresses of the whole address space. So we really have just cut this address space in half. It went from 0 to 255 and now it goes from 0 to 127 and from 128 to 255. The usable hosts for network A are going to be from .1 to .126, and the usable hosts for network B are going to be from .129 and to .254. For the purposes of this course, the standard we're looking at, that first usable address, so that first usable address that we're seeing, the .1 and the .129, would usually be our default gateway for that network. It's not necessary, but it's a standard that we've been using. So how do I say this? So 2 subnets, we need 1 binary bit to represent 0 and 1. For 4 subnets, we need 2 binary bits to represent 0, 0, 0, 1, 1, 0, and 1, 1, which is 0, 1, 2, 3 in binary. For 8 subnets, we need 0, 0, 0, so we need 3 bits, because we need 0 through 7. So here we need 0 base 10 to 3 base 10. Here we need 0 base 10 to 1 base 10. Here we're going to need, I'm going to have to write this on the other side so I have room. 0 base 10 to all the way down at the bottom, we're going to need 7 base 10. So 0, 0, 1, 0, 1, 0, that's 1 base 10, 2 base 10, 0, 1, 1, that's 3 base 10, 1, 0, 0, that's 4 base 10, 1, 0, 1, that's 5 base 10, 1, 1, 0, that's 6 base 10, 1, 1, 1, that's 7 base 10. So what we've done here is we end up with 8 possible subnets, 4 possible subnets, and 2 possible subnets. If we wanted to go to 16 subnets, we would need to go from 0, 0, 0, 0 to 15, which is 1, 1, 1, 1. So every time we double the amount of subnets we have, we need to add another bit, is essentially what we're saying here. It's pretty unlikely we'll be getting into a lot of those bigger ones this early on, but we'll look at some practice as well. The next example that we're going to do is also not going to line up nicely like a classful address on the octet. So it's not going to line up on the octet. It's going to line up in the middle of an octet. So for this example, we're going to do 209.192.64.0/19. I don't want to have to make you do a lot of binary conversion here. So first I'm going to write this address out for you in binary, and I'll write out the maximum broadcast in binary. And then I'm going to have you just pause the video and try this on your own. So again, in binary, this address is written the same until we look at those network bits. So 64 is 0100 0000, and 0 is 8 0 bits. So in this case, we're now looking at a network separation at 19. So we know we have 8 here, we have 16 bits at this point, so we have 17, 18, 19, so our network is going to split right there. What we're going to do from here is we're going to write out the host bits. So we know that for the network, all of these zeros are host bits. And we know for the broadcast, all of these host bits are ones, and these are still network bits, so they don't change at all. So what we're going to do is we're going to quickly convert this to give us our starting network address and our starting broadcast address. I'm just going to move this yellow line, make it a little bit shorter. Okay, so our starting network address is 209.192.64.0/19. Nice and easy. Our starting broadcast address is 209.192. Be careful here because 64 is broken apart. So in fact, we're not looking at 64, we're looking at 95.255 again /19. So this one doesn't line up on an octet, so we're not going to get a nice similar network mask in both the broadcast and the network. So we know we're working with all the address space between 209.192.64.0 to 209.192.95.255. So I'm going to have you break this into two networks. So you're going to need to you're going to need two states. So break it into two networks, just two subnets. Two states equals 1 bit borrowed. So using that information, I would like you to now pause the video, write out the network address in binary, and see if you can figure out what the network and broadcast addresses are for subnet A and for subnet B. Okay, so at this point in the video, I'm assuming that you've paused and you've attempted this question. To give me a bit of a head start so you don't have to watch me writing out binary digits a lot, I've already written out the network address, and I've written the network portion in red, and I've written the host portion in white, just to make it a little bit easier to follow, I'm hoping. So I know I'm going to need to borrow a host bit and turn it into a network bit. And I'm only going to need two possible states. I'm going to need to turn this bit into a network bit. So I'm going to need a 0 and a 0 for the network and the broadcast. I'm going to need a 1 and a 1 for the network and the broadcast of subnet B. So now our host bits are for the broadcast are all ones. And for the for the network address for subnet B, the host bits are all zeros, and the network bits are again all ones. And I'm going to go ahead and finish writing this binary in the network portion. It's not going to change at all, but I like to have the whole binary part written out, at least for the part that changes. I know that this section isn't going to change, and I know this section isn't going to change, so I don't usually write them out. They stay the same all the way down. I find it's just a waste of time for me to write it out, but if you find it's helpful to you, you should definitely be doing that. Okay, so our network address is going to split into subnet A and subnet B. And we're going to need to calculate a network and a broadcast for each address by converting our binary to decimal. So we know that the 209.192 does not change. This first address is 64.0. We're again just converting this section here. Okay. The broadcast address is this address right below it with all the ones in it. This one is going to be 209.192 and this time it's not 64, it's actually going to be 79 because we're converting 1 or 0, 1, 0, 0, 1, 1, 1, 1, dot 255. We're going to look at the subnet B's network address, which is going to give us 209.192.80.255. And then we're going to have a broadcast of 209.192.95.255. That's coming from this subnet section down here. And what we'll see is that we go from 64.0 to 95.255. If we reference back to when we calculated the full network in broadcast, we'll see that we had 64.0 and we had 95.255. So we did in fact split that whole address space right in half, which is a pretty good way to go. What we're going to look at now is what happens if we break another network into a /4 network. I'm only working with I'm only working with breaking networks into 2 subnets or 4 subnets in this video because I do want you to have some chance to practice, but I don't want us to be writing out tons of subnets because that can take quite a long time and you might just check out of this video. Okay, so I'm just going to make myself a little bit more space to do this one. I'm going to start this particular address in a totally different place. So I'm going to start with 192.168.140. Sorry, that first digit there is a 1.0. And I'm going to say this is a /27 network. At this point, you're going to break it into 4 subnets. And those of you who think you can go from here, pause now and then go for it, and then you'll walk through the example after. For those of you who are a little bit struggling with binary still, I recommend you use the Windows calculator to do your binary conversions, but I will write out the network for you in binary. 168 is 10101000. Get that one quite often. 140 is 10001100, and then 0, nice and easy, all zeros. If we're looking at where the network breaks, it's a /27 network. So we are looking at a 8th bit, 16th bit, 24th bit. We're quite used to those ones. 25, 26, 27. Our network break is going to happen there. And so we know that these bits are all our host bits. So the last 5 bits are our host bits. So from there, you need to decide how many bits are you going to borrow, which bits are you going to borrow, and how are you going to write this out in binary from this point. So if you haven't yet, pause to try this. Pause now, try the question. Okay, so at this point, I'm assuming that you've already attempted this question, and you hopefully have your 4 network addresses and your 4 broadcast addresses for your subnets A through D. So I'm going to go ahead, and I'm going to break this network break down a lot further, because I know I'm going to end up with 8 addresses. And then I'm going to fill in the network portion of the address, which I know doesn't change for all of my addresses, just to confirm that it is in fact not changing. So we have our network and broadcast, network and broadcast, network and broadcast. We need our 4th subnet here. And we know that we're going to need to actually borrow 2 bits in order to break into 4 subnets. So I'm going to write those in red because they are now network bits. So broadcast, network, broadcast, network, broadcast, network, broadcast. And I'm going to go fill in the host bits. Broadcast host bits are all 1s, network host bits are all 0s, broadcast are all 1s, network are all 0s, broadcast are all 1s, network are all 0s, broadcasts are all 1s. Okay. So what we're going to do is we're going to quickly convert this over to denary. So we have A, B, C, and D. We have a network address and a broadcast address for each. So the network address for the first one is going to be 192.168.140.0. Remember, these are now /27, 28, 29. So this is now a /29 network. So 192.168.140.0, our broadcast is 192.168.140.0. 192.140.7. It's this conversion here. And again, it's a /29. These are all /29 networks because we're using 29 bits now. We previously had 27, 28, 29. So our network B is going to be 192.168.140.8, which we can see here, but we could also potentially just notice is one more than the broadcast of the previous subnet. 192.168.140.15, 192.168.140.16, 192.168.140.23. That's coming from this broadcast here. And we have 192.168.140.24. And we have 192.168.140.31, which is coming from this address here. Just give you guys a little bit of hints as to what I was doing. Okay, so hopefully you were able to do this calculation yourself. I'm not sure I actually mentioned the slash notation. I'm hoping that you know that you can count the network bits. So if we have 2 more network bits, a /27 network becomes a /29 network. Just to go back and reference some of the examples we had done previously. Here, we went from a /19 network and added a bit. So all of these addresses are /20 networks. In the very first example, we went from a /24 network and we added 1 bit. So all of these network addresses that we ended up with here, I'm going to write in white because I think it'll be more visible, are going to be /25 networks. Okay, so you just, however many bits you borrow, you add to the previous prefix notation, and that will give you the new prefix notation. You could also just count the network bits. And that's everything I have to say about subnetting networks. So if we're looking at subnetting network addresses, this is the math behind it and how we actually calculate the new network and the new broadcast address. At this point, I'm going to stop this video because I have covered a lot of math here and it's a lot to take in. In the next video, I'll go over how we decide on what's the default gateway, how do we decide how we want to subnet, and then we'll have another video on variable length subnets. So we've been separating into exactly 2 networks of the same size, or exactly 4 networks of the same size, or exactly 8 networks of the same size. But what happens if we want to split into 2 networks of the same size and 2 networks that are smaller, or 4 networks that are smaller? So we're going to look at that in a future video. So hopefully this helped you with subnetting. Best of luck to you in your activities.